Hello students, once again welcome you to GK's Applied Maths classes. Today we are going to continue with probability. We are going to do Poisson distribution. I will introduce you to the concept of Poisson distribution and related formulas, and we'll try to solve example and exercise problems from CBSE handbook. Okay, so straight away let's go inside the Poisson distribution. Now what is this Poisson distribution? Now, you know binomial distribution, n is the number of trials, right? If you remember binomial distribution, n corresponds to number of trials. Number of trial. And p is nothing but probability of success. So you know this. Now, if n is very, very large, okay, suppose n is very large, and you know the formula for binomial for x is equal to r success is NCR p to the power of r q to the power of n minus r. Now if n is very, very large, okay, so when n is large and if p is small, okay, when I say large, I mean when n tends to infinity, and when I say p is small, when p approaches to 0, okay, then it becomes very difficult to use this formula because the n is very large. It is very difficult to use this formula to do the calculation. Okay, it becomes very cumbersome. Okay, when you use when n is large and p is small, using binomial formula, binomial distribution formula becomes very, very difficult. So what we do is, when n is very large, that is when n approaches to infinity, very, very large, and when p approaches to 0, not only that, your np must be constant. Your mean should be constant, okay, or it should be a finite value. So when n is very large, p approaches to 0, and np is a final value, for np is a finite value, then you can say your Poisson distribution, okay, is a limiting case of a binomial distribution. So in a binomial distribution, when I tend n to infinity and when I allow p to approach to 0 with mean remaining constant, then I can say the binomial distribution approaches to Poisson distribution. Okay. Now a simple example is, if you take a traffic junction, you can say the number of vehicles that approaches the traffic junction, say for example 10,000. So this n is relatively small, relatively large. Okay. Now p is a person meeting an accident, okay, accident in the traffic junction, So let us say you experience 2 accidents per day, okay, so 2 out of 1,000, which is very, very small, or 2 out of 10,000, so it's very, very, very small. P is very small, n is very, very large, okay, and your np is a fixed number. If you multiply them, you get this. Suppose if I take this as n and this is p, np is a fixed number. So this situation satisfies a Poisson distribution. That means in a particular traffic junction, when thousands and lakhs of vehicles are moving, the number of accident that takes place in that junction is going to be very, very small. Okay, such event will satisfy Poisson distribution. Or a person coming to a queue and purchasing a ticket. Many people will come and purchase the ticket in a queue. You see, arrival of a person in a booking counter. A particular person coming to a booking counter and taking the tickets. That also satisfies Poisson distribution. So where n is very large, the number of people coming to the queue is large, and a particular people coming to that particular group is going to be very small. So n is large, p is small, NP is a constant, it satisfies Poisson distribution. Now there is a formula that you should know for Poisson distribution. P of x is equal to r equal to e to the power of minus lambda, lambda power r by r factorial. Now what is lambda? Lambda is called the mean, otherwise it's called the expectation of x. Okay, lambda is the mean, and lambda mean is same as the variance. In a Poisson distribution, there is no difference between mean and variance. In a Poisson distribution, there is no difference between mean and variance. Okay, so don't forget this formula. This is going to be very useful. So Poisson distribution is a limiting case of a binomial distribution where n is very large, p is relatively small, and np is a constant. Okay, let's do the first problem here. Now, what does the first problem indicate? Now, as the story goes, okay, a Persian soldier, okay, monitored 10 cavalry corps over a period of 20 years. The annual number of recorded deaths due to an accident, here the horse kick, okay, in K observation is given here. For 0 observation, 109 people have died. For 1 observation, 65 people have died. For 2 observation, 22 people have died. 3 observation, 3 people have died. For 4 observation, 1 person has died. And totally, there are 200 people. And there are totally 200 deaths. Now, you want to know whether this data is adequate to satisfy Poisson distribution or not. So, what I will do here is, first of all, I will find the mean. Now, how do I find the mean? Mean will be fi xi by fi, total of, okay, then say sigma fi xi by sigma fi. Now how do I do? Multiply this 0 plus 65 plus 44 plus 9 plus 4. Fi, this is like your xi and this is like your fi. So if you multiply 0, 65, 44, 9 and 4 divided by total of fi. Total fi is 200. So it is 122 divided by 200, which is approximately 0.61. Now what I will do, I will try for 0 observation. I will try to calculate the probability for 0 observation using the mean that I have calculated. So what is the formula? E to the power of minus lambda, lambda power r by r factorial. Here my r is 0. So e power minus lambda, lambda power 0 by 0 factorial. What is this? This is actually e to the power of minus 0.61, which is 0.54. 0 factorial is 1, so, and lambda power 0 is also 1. Now if you find p of x is equal to 1. Now what is p of x is equal to 1? E power minus lambda, lambda power 1 by 1 factorial, which is e to the power of minus 0.61. Lambda is 0.61 whole power 1 by 1 factorial. So if we do the calculation, I am getting it as 0.33. Now I find p of x is equal to 2. When you do p of x is equal to 2, you get e power minus lambda, which is e power minus 0.61 into 0.61 the whole square by 2 factorial. I think I am getting calculation as 0.1. Then you find p of x is equal to 3, which is e power minus lambda, lambda cubed by 3 factorial. So it is e power minus 0.61 into 0.61 the whole cube by 3 factorial. I think it is 0.02. And finally, I find for p of x is equal to 4, which will be e power minus lambda, lambda power 4 by 4 factorial, which happens to be 0.003. 0.003. Now this is the probability calculated for x is equal to 0. Okay, that is for one person. Okay, now I want to know for 200. So what I will write, number of death predicted using Poisson distribution. What will be that? 0.54 into 100 into 200. There are totally 200 deaths. Okay, I am using the Poisson distribution for that, and it comes out to be what? I think I am getting it as 108. And if you notice, 108 is very close to 109. Correct? So this observation sounds good. Now, then I do for 0.33 with 200. What do I get if I do 0.33 with 200? 0.33 with 200 gives me 66, which is approximately 65. So for one also it works. So the one which I am predicting using Poisson distribution matches with what observation that we have. Okay. Now this is 0.1 into 200, which is 20, and it is almost there, 22. Then it is 0.02 with 200. It is 0.02 with 200, which is like 4. Almost equal to 3. Yes. And finally 0.003 with 200, it gives you 0.6, which is approximately equal to 1. So these values are almost identical with this, correct? So what we will say, yes, this data provide adequate description of Poisson distribution. So these are the predicted values that I have got using Poisson distribution, and it is almost equivalent to the observation that is given. So they match. That is why yes, it is adequate. Now, a traffic engineer records the number of bicycles that uses a particular cycle track. He records that an average of 3.2 bicycle riders, average. So my lambda is 3.2 for every 1 hour. Here also it is for 1 hour, so that is my average, 3.2. Now he wants me to find x less than or equal to 2. What will be x less than or equal to 2? P of x is equal to 0, P of x is equal to 1, and P of x is equal to 2. What is P of x is equal to 0? E power minus lambda, lambda power 0 by 0 factorial, plus e power minus lambda, lambda power 1 by 1 factorial, e power minus lambda, lambda square by 2 factorial. So this is, what is e power minus lambda? E power minus 3.2, and lambda power 0 is 1. Okay, so it is 1 plus lambda power 1. What is lambda power 1? 3.2, and 1 factor is 1, and this is 3.2 the whole square by 2. So this is 0.041 into 4.2, plus when I calculate this, I am getting it as 10.24 divided by 2, which is 0.041 into 4.2 plus 5.12 which is 0.041 into 9.32. So when we calculate this, what do I get? I'm getting the answer as 0.38212. Now the second part of the question, P of x is equal to, x is greater than or equal to 3, which is same as 1 minus P of x less than or equal to 2, which is 1 minus, what is P of x less than or equal to 2? We have already calculated as 0.38212, which is nothing but 0.61788. Okay, now let's go to the next question. Now here a particular river near a small town floods and overflows twice in 10 years. It overflows twice in 10 years. So it overflows 2 times in 10 years. Assuming that the Poisson distribution is appropriate, what is the mean expectation? Also calculate the probability of 3 or less overflows in 10 years. So my lambda will be 12. This is the mean. Okay, it floods twice in every 10 years, so that is the average. Now I want to find P of x less than or equal to 3, which is P of x is equal to 0 plus P of x is equal to 1 plus P of x is equal to 2 plus P of x is equal to 3, which is e power minus lambda, lambda power 0 by 0 factorial, plus e power minus lambda, lambda power 1 by 1 factorial, plus e power minus lambda, lambda square by 2 factorial, plus e power minus lambda, lambda cube by 3 factorial. This is e power minus lambda is common. I get 1 because lambda power 0 is 1. This is lambda plus lambda square by 2 plus lambda cube by 6. E power minus lambda is e power minus 2 into 1 plus 2 plus 4 by 2 plus 8 by 6. So e power minus 2 is 0.135 into, this is 2, 4 is 5 plus 4 by 3, which is 0.135 into 19 by 3, and when we calculate that, I am getting it as 0.855. So it's pretty easy calculation. Now the next question is, for a Poisson distribution model, if arrival rate of a passenger in an airport is recorded as 30 per hour, so 30 passengers, 30 persons in 1 hour. 1 hour is same as 60 minutes. Here the calculation is on 10 minutes. Okay, expected arrival in the first 10 minutes. So I have to convert the 60 minutes to 10 minutes. So what I will do, I'll divide by 6 equal to 10 minutes. So my average is 5. This is for 10 minutes. Okay. Now the expected number of arrival in the first 5 minutes. That is my subdivision A. That is done. Now let's go to subdivision B. What is subdivision B? Probability of exactly 4 arrival. So P of x is equal to 4. Now what is P of x is equal to 4? E to the power of minus lambda, lambda power 4 by 4 factorial, which is e power minus 5, 5 power 4 by 4 factorial, which is e power minus 5 is 0.0067 into 625 divided by 24. So when I do the calculations, I am getting it as say roughly it is 0.176. I think you can do the calculation part by yourself. Okay, points. Okay. Now the C subdivision. Probability of 4 or fewer arrivals. 4 or fewer means x less than or equal to 4. So which is P of x is equal to 0, P of x is equal to 1, P of x is equal to 2, P of x is equal to 3, and P of x is equal to 4. So what do you mean by P of x is equal to 0? E power minus lambda, lambda power 0 by 0 factorial, e power minus lambda, lambda power 1 by 1 factorial, e power minus lambda, lambda square by 2 factorial, e power minus lambda, lambda cube by 3 factorial, e power minus lambda, lambda power 4 by 4 factorial, just applying the formula. Now take e power minus lambda outside, you get e power minus 5 is common, you get 1 plus lambda is 5, right? So it is 5 plus 25 by 2 plus 125 by 6 plus 625 by 24. So which is e power minus 5 into 6 plus 12.5 plus 125 divided by 6 will be 20.83, and this will be 26.04. So when I calculate this, I get e power minus 5. E power minus 5 is what? 0.00674 into 65.37, which happens to be 0.44. This part is very simple. Everyone knows this. So the last subdivision is a little complicated. You have to be very, very careful. The probability of 10 or more arrival in an hour. I want to find 10 or more arrival in 1 hour. But he has given something very interesting. What is it given? 100% we are sure that there will be 8 arrival in the first 10 minutes. So 8 arrival in 10 minutes. In the first 10 minutes I get 8 arrival. If I want to get 10 or more arrival, I should get 2 or more arrival in the next 50 minutes. Yes or no? If I want to get 10 or more arrival in 1 hour, when I know for sure I will get 8 arrival in the first 10 minutes, I should get 2 or more arrival in the next 50 minutes. So my problem revolves now around this 50 minutes, not with this 10 minutes, because this is a sure event. Okay. Now what I will do, in 10 minutes, you have 5 arrival, right? That's what we have done here. In 10 minutes, we have 5 arrival. So in 50 minutes, there will be 25 arrival. So this is my new lambda for this subdivision. For the subdivision D, my lambda is 25. Now what I want to find? I want to find 2 or more arrival. So I want to find P of x greater than or equal to 2. Now what is P of x greater than or equal to 2? See, 0, 1, 2, 3, 4, so on. So I want to find greater than or equal to 2, which is same as 1 minus P of x is equal to 0 plus P of x is equal to 1, which is 1 minus, what is P of x is equal to 0? E power minus lambda, lambda power 0 by 0 factorial plus e power minus lambda, lambda power 1 by 1 factorial. 1 minus e power minus lambda is common. I get 1 plus lambda is 25, so it is 25. e power minus 25 is a very, very small number, so we leave the answer as it is. Okay. The best part of this problem is we are not calculating this because this is a sure event. In the first 10 minutes, 8 people will definitely come. 2 or more people in the next 15 minutes is what we are calculating. Okay. For that, you have to find a new lambda. Okay. Next one. A statistician records that the number of trucks approaching a particular intersection to analyze the flow of traffic. So, in an average, you have 1.6 people. Average is 1.6. Assuming that the truck approaching the intersection follow a Poisson, it satisfies the Poisson distribution model. What is the probability that 3 or more will approach the intersection? So I want to find 3 or more, which is same as what? 1 minus P of x is equal to 0, P of x is equal to 1, and P of x is equal to 2. 3 or more will be 1 minus P of x less than or equal to 2, which is 1 minus e power minus lambda, lambda power 0 by 0 factorial, e power minus lambda, lambda power 1 by 1 factorial, e power minus lambda, lambda square by 2 factorial. So this is 1 minus e power minus lambda. What is lambda? Minus 1.6. This is 1. Lambda is 1.6 plus 1.6 the whole square by 2. So this is 1 minus, what is the e power minus 1.6? It is 0.202, and this is 2.6 plus, this is 2.56 divided by 2. 2.56 divided by 2 will be what? The calculation I have done, it's 1.288. So this is 1 minus 0.202 into 3.88. And when we do the calculation, I am getting it as 1 minus 0.784. So when we do the calculation, it's 0.216. Very simple calculations, not difficult at all. Now let's go to the next question, question number 14. Now here, a computer disk manufacturer tests disk quality on random basis before approving it. The approval is based on the number of errors on the disk. It satisfies the Poisson distribution. So your lambda is already given. Lambda is 0.2. What percentage of the test area having 2 or smaller number of errors? So P of x, which is P of x is equal to 0 plus P of x is equal to 1 plus P of x is equal to 2. Now what is P of x is equal to 0? E power minus lambda, lambda power 0 by e power minus lambda, lambda power 1 by 1 factorial, e power minus lambda, lambda square by 2 factorial. E power minus lambda is common, so I get 1 plus lambda square by 2 factorial, which is e power minus 0.2 into 1 plus 0.2 plus 0.2 the whole square by 2 factorial, which happens to be 0.819 into 1.2 plus, actually it is 0.22, 0.22, correct? So when we do the calculation, what do I get? Actually 0.02. Okay. It is 0.819 into 1.22. So when we multiply this, I am getting it as 0.999. Since I want to calculate the percentage, I multiply by 100. So 99.9% is the answer. So the question is asked what percentage? Okay. Now let's go to the next question. This is a very, very simple question. It's given mean is 2. What is variance? You know variance is the same as mean in a Poisson distribution. So the variance is also 2. No, there's nothing to do in that. Now the next question. It is given that 3% of the defective electric bulb are manufactured by a company, using Poisson distribution, find the probability of 100 bulbs contain no defective bulbs. So my lambda will be 3. 3 out of 100 is defective, so lambda is 3. And I want to find P of x is equal to 0. E power minus lambda, lambda power 0 by 0 factorial, which is same as e power minus 3, 0 factorial, and the lambda power 0 is 1. So answer is 0.05. Very simple, straightforward question. Now question number 11. The mortality rate of a certain disease is 7 in 1,000 people. 7 in 1,000 people. Using Poisson distribution, calculate 2 deaths in a group of 400 people. If the question was in a group of 1,000 people, my lambda would have been 7. But here you want me to calculate in a group of 400 people. So what I do? 7 by 1,000 in one person will die. Okay, out of one person, 7 by 1,000 will die. I want to calculate for 400 people. So for 400 people, it will be 7 by 1,000 into 400, which is 28 divided by 10, which is 2.8, is my average. 2.8 is the average number of people who die of mortality, who die, okay, out of 400, whereas 7 is the mean for 1,000. I am converting it for 400 because that is what is asked in the question. Now he wants to know P of x is equal to 2. What is that? E power minus lambda, lambda square by 2 factorial. What is e power minus lambda? E power minus 2.8 into 2.8 the whole square by 2. E power minus 2.8 is given as 0.06 into, this is actually 5.76, I think, right? 7.84. 7.84 by 2. So if you calculate this, I am getting it as 3.92 into 0.06, which is approximately 0.235. It's all calculations. Take care of the calculation. An ice cream parlor receives at an average of, should be 16. Okay. Now what I want to find? I want to find P of x is equal to 16. Correct? So P of x is equal to 16 will be, this is 16 because 4 into 4. Okay. P of x is 16 will be e power minus lambda, lambda power 16 by 16 factorial, which is e power minus 16 into 16 power 16 by 16 factorial. This is the answer. Please understand, here in an ice cream parlor, the average is 4 per minute, but he wants to calculate for 4 minutes period. Since it is for 4 minutes period, it will be 16 people. So lambda will be 16. It has nothing to do with this 16. Don't get confused. Okay. Then he wants to know that 16 customers will be coming. So P of x is equal to 16, which is nothing but this. Okay. Now I have to do this example. This is a little lengthy example from the NCERT book, example 12. Okay. This is example 12. Please go through it. Calculation is very, very lengthy, so that is why I am not going to do it. Okay. So just make a note of this, example 12. It's already worked out, so I think you should be able to do it. In case you have difficulty, please put it in your comment section. I hope this video is useful to you. We'll continue with normal distribution next class. I hope kindly subscribe to my channel and also click the bell icon to get notifications. Thank you very much for watching the channel. Have a lovely day.